So in this video, I'll show you how to conduct a hypothesis test of a proportion. So here I've already cleaned my data for Montreal in that I'm only interested in the Ville Marie neighborhood. So I've gone in and I've deleted any row that is not a listing in Ville Marie. I've also cleaned up my property types. I'm only interested in apartments, condos, houses, and townhouses. So again, I removed any listing that's not one of these four types. And I've cleaned up my accommodations. I was interested in listings that accommodate two or more. So I removed any listing that was one or less. So for a proportion, this is the percentage of something. So I'm interested in the proportion of houses in Ville Marie. So I'm going to select my data here and create a pivot table so it will count my property types so I don't have to. So I'll go Insert and Pivot Table and hit OK. Make sure it does select the column that you want, in this case property type. I hit OK. And I'm going to drag and drop property type into rows as well as into values. So let me go ahead and zoom in. So now we can see here are the counts of my property type, and I can see that the number of homes is pretty low. There's only 31 houses out of 1,503 listings. So to get the sample proportion, or P-bar, I'm going to take 31 houses divided by my 1,503 listings. So this gives me a sample proportion of 0.02 or 2%. And then I'm going to conduct a hypothesis test around this, in that my hypothesis would be that there are less than 10% of houses in Ville Marie, or the proportion of 0.10. And I provided a worksheet to walk you through the process for hypothesis testing with this data. So let's say our hypothesis test for the population proportion states that our P is greater or equal to 0.10, or 10% of our listings are homes. And so the alternative that I'm hoping for is that it's going to be less than 10% or 0.10 homes. Because again, if there are not that many homes, but rather there are many apartments and condos and townhouses, that means we're in a densely populated urban area that would be well suited for a bike tour business, because there's more potential customers and listings all in one place. So here I'm going to use an alpha of 0.05 because it's commonly used. I like working with it, so I'll keep it simple. My N is the 1503, and the sample proportion that I found using Excel by taking my number of homes, which is 31, divided by the number of listings, which was 1503, that gave me a sample proportion of 0.02. So only 2% in my sample data were houses. But I have to account for sampling error, which is why I'm going to conduct this hypothesis test to see if my alternative hypothesis is true or not. So for our decision rule, it's helpful to note, is this an upper or lower tail test? So because our alternative hypothesis says less than, we know this is a lower tail test. So for my decision rule, we will reject the null if the calculated value of our test statistic is less than the critical value. And so you can use the appendix F to find the Z critical value, or we can use Excel. In this case, since it's a lower tail test, if I use Excel, I would plug in norm.s.inv and my alpha value of 0.05. So my critical value will be negative 1.645. Remember, it's negative because we're on the left side. It's a lower tail test. So for our calculated value of the Z test statistic, I'm going to plug in my various numbers. So my sample proportion of 0.02 minus my hypothesized population proportion of 0.10. And then I'm going to square root my population proportion, that's the 0.10 times 1 minus 0.10 divided by 1503, my sample size. And then I square root the entire thing. So when I go ahead and start to solve, my sampling error up top will be negative 0.08, and my standard error in the denominator is 0.0077. When I divide these two numbers together, I get negative 10.33. So now I can make my decision using the critical value method. Because our z-test statistic of negative 10.33 is less than my critical value of negative 1.645, I will reject the null. So by rejecting the null, that means my alternative hypothesis is true, which is great because that means, yes, the proportion of homes in Villa Marie is less than 10%. That means we have a very large proportion of our listings that are not homes, in this case, apartments, condos, and townhomes, which is great because then that means this area is densely populated and my bike business would have lots of customers available in the area.